everyone, hello lovely students, welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So we have got these two questions for today's session and you have to find the range. And I request you all to pause the video, read these questions carefully and try to solve them on your own. Alright, now let's solve these questions with me. And before we get into solving these problems, I would like to say a few basic concepts for finding range. And perhaps many of you might be aware of it in advance. So the first concept is, let's say we have an expression e of x. We have an expression e of x and let's say its range is given as closed A to closed B and we are asked to find the range of e of x plus k, where k is any real constant other than 0. It can be positive, it can be negative. Then to get the range of e of x plus k, we simply add the constant k to the left hand boundary point and to the right hand boundary point. So the left hand boundary point is a, so we add k to the left hand boundary point and we add k to the right hand boundary point, and this will give us the range of the functional expression e of x plus k. So you have to remember that whenever a functional expression whose range is given to you and you were asked to find another functional expression by adding some constant, then you simply add the constant to the left hand boundary point and to the right hand boundary point of the previous function. Alright, let's say for the same expression e of x, if it is open from one side and closed from the other side, just we take some example. Let's suppose e of x is given to you as open A and B close. So the range of e of x is a to b and the left hand boundary point is excluded from the range because we have a round bracket, and the right hand boundary point b, we have a square bracket, that means b is included in the range. So we are asked to find out the range of e of x plus k, where k is any real constant, positive or negative. So the working rule is same just like the previous one. We simply add k to the left hand boundary point and we simply add k to the right hand boundary point, and the open and the close will be taken care of as well. So the new range or for the new functional expression comes out to be a plus k to b plus k, and the left hand boundary point is again excluded and the right hand boundary point is included. So you have to be careful with this. Now let's say again, if for the same expression e of x, if it is closed from A and it is open from B, then for e of x plus k, we simply again add k to the left hand boundary point and to the right hand boundary point. And if e of x is given as open A to open B, it is open from both sides, and open from both sides means both the boundary points, the left as well as the right, they both are excluded from the range. So to get the range of e of x plus k, where k is a positive or negative real constant other than 0, we simply add the constant to the left hand and the right hand boundary point. Hope you all understand this. Now let's get back to our questions that we are supposed to solve for today's session. Okay, so the first question, we have sine of x minus 7. So for sine of x minus 7, you all must be knowing in trigonometry that the range of sine of x is closed minus 1 to closed 1. So minus 1 to 1 is the range of sine x, and we have a square bracket at the left hand boundary point. That means left hand boundary point is included in the range, and we have a square bracket at the right hand boundary point. That also means right hand boundary point is included in the range. So we have another, let's say we write this expression like this. Okay, so we have added a negative constant number to sine of x, which in this case is minus 7. So from sine x, to get the range of sine x, plus minus 7, we'll add the constant negative 7. So just a few seconds back, I have taught you that if you add some constant to get a new functional expression, then for the range, you will add that constant to the range of the previous function to the left hand boundary point and to the right hand boundary point. So we add negative 7 to the left hand boundary point and we add negative 7 to the right hand boundary point as well. Okay, just let me fix this for a while. So we add negative 7 to the right hand boundary point and we get negative 8 and we get negative 6. So this is the range of sine of x minus 7, which is actually your fx. So the range of fx comes out to be negative 8 to negative 6 for the first question. Now let's solve the second one. The second one we have, this is a fractional part function. Hope you are all aware with this fractional part function. You were taught this in your 11th standard. So for the second question, this is the solution of first and this is the solution that we are going to do for the second one. So for fractional part of x, its range is close 0 to open 1. And we have to find the range of fractional part of x plus 5. So don't you see that we are adding a constant, a positive constant to the function. So let's do that. So if we add the constant 5, then just I have taught you a few seconds back, you will add 5 to the left hand boundary point and to the right hand boundary point as well. So you add 5 to 0 and you add 5 to 1. So we get 5 to 6 and this is your fx actually. So the range of fx comes out to be, just a second, let me fix this. So the range of fx comes out to be close 5 to open 6. That's all for today's session. So this was all about today's session and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming videos. See you all my lovely friends in my next upcoming videos with more exciting and a lot of awesome questions. Till then, bye bye, stay safe and have a nice day.